So section 3-4 is called perpendicular lines, and most of you know what a perpendicular line is, and you know a little bit about it. And we'll go over a few of these things, but this section in the geometry book, because this is college prep geometry, will actually go into a little more detail. So obviously, perpendicular lines are 90 degrees to each other. We use this little symbol. It's an upside down capital T. You what? You should go on my YouTube channel when you get home. Okay? And then we're going to talk about something called a perpendicular bisector. It's going to be halfway on a segment. Okay? So if you have a segment, we'll call this segment RS, and if you all have these fancy things called compasses, which have like a pointy stick on one side and a pencil on the other, you would put your pointy stick on R and you would make an arc with the pencil that goes like this. Okay? Then you would move your pointy stick over to S and you'd make another arc, and they would intersect right here and right here. Then you would take your ruler and you would draw in a line. That line right there is what we call the perpendicular bisector. And it is also the midpoint of that segment. So you have a midpoint right there. Okay? You also can put this little box, right? That little box represents that it's 90 degrees, that it's perpendicular, which also creates two what we call congruent segments. So if we call this point T right here, then we can say that segment RT is congruent to segment ST. Okay. So a lot of things happen with this construction. So this is called a construction, and you can duplicate this if you have one of those fancy compasses, okay? So let's talk about what the book calls distance from a point on the line. Okay? So we're going to put a point right here. We'll call it point P. Okay? And then we're going to draw a line underneath it. We'll call it line L. Now, to get from point P to line L, you can take the long route. You can go okay? That route takes you a really long way, okay? This book says that the shortest distance from a point to a line is a straight line, and that line happens to be perpendicular, okay? Where it's perpendicular is the shortest distance. Versus any other route or any other line, going to that line is going to be longer than that. We'll call this route X. We'll call this route P because it's perpendicular. X is always going to be greater than P. Any other route that's not perpendicular is going to be the longer route. Okay? So we're going to look at an example, we'll call it number 1, and you're going to see one of your very first what we call two-column proofs, okay? So two-column proofs, you're going to be given a statement. You've seen a couple of them on the worksheets, but we haven't gone over them in really detail. You're going to be given some information that such things like line R is parallel to line S, and angle 1 is congruent to angle 2, and then you're going to be asked to prove something. And in this case, you're going to be asked to prove that the lines are perpendicular, that upside down T, perpendicular, okay? So we're going to draw line R so that it's parallel to S. So over here, we're going to sketch whatever they tell us. So here's line R, and then we'll draw another line, and we'll call it S. So R is parallel to S. So I'm even going to put the little caret thingy on there. There's a little caret. There's a little caret. That shows that they're parallel. And we've got another statement that angle 1 is congruent to angle 2. Okay, so I'm going to draw a third line, and we're going to label some angles. We'll call this one right here 1, this one right here 3, and this one right here 2. So angle 1, angle 3, and angle 2. And this statement says that angle 1 is congruent to angle 2. So we're going to create what's called a 2-column proof. Okay, for a 2-column proof, you need 2 columns. So you're going to draw like a little table with 2 columns in it. 1 column, 2 column. So in the column on the left, you're going to have some statements. And in the column on the right, you're going to have what we call reasons. So reasons can be anything from definitions to theorems to corollaries, anything that you have learned so far in geometry that will help you prove that your statements are true. So the first statement we're going to start with is what we were given. So we were given that R is parallel to S, and we were also given that angle 1 is congruent to angle 2. Both of these were given. And that's all you have to say for the reason of what you're given. The second statement we're going to say is any way we can see a relationship between any of these angles, 1, 2, or 3. So I'm noticing that angle 2 and angle 3, as you follow that transversal down, they're in the same position. Therefore, they're called what? Corresponding, okay? So we're going to say that angle 2 is congruent to angle 3. Why? Because they are corresponding. Okay, and if those lines are parallel, which they are, then they should be congruent. Okay? Step number 3, we'll see what we can have here, right? We have angle 1 is congruent to angle 2, and we have angle 2 is congruent to angle 3. So if angle 1 is congruent to angle 2 and angle 3 is congruent to angle 2, we can say that angle 1 is congruent to angle 3 because they're both congruent to angle 2. Okay, that's what we call the transitive property. The transitive property works because angle 1 is congruent to angle 2 and angle 3 is congruent to angle 2. Therefore, if you cross off the angle 2's, you've got angle 1 and angle 3. So that's what we wrote for statement number 3, that angle 1 was congruent to angle 3. Okay, so if 1 is congruent to angle 3, then they must be perpendicular, which is our fourth statement. R is perpendicular to T because they form a linear pair. Okay, they're congruent to each other. They're going to form a linear pair. They are also 90 degrees. Okay, I'm going to move this up. If you're still writing, you'll see it in just a second. angles. Okay. All right. We have 3 theorems that we need to talk about. And as usual, I'm not going to make you write the whole theorem out. We're simply going to draw a picture to represent it and write a little bit about it. If you want to see the full theorem, you can go to the my.hrw.com website, and it'll tell you the whole wording for the whole theorem. But I'm going to read it to you. The first one is numbered 3-4-1. So this is Chapter 3, Section 4, the first theorem. Okay? And here's what it says. If 2 intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. Okay? So we have 2 intersecting lines. They're going to form a pair of congruent angles. They're going to be perpendicular. So it's almost what we just talked about in example number 1. It's very similar. So we've got line L, and the line intersecting them forms 2 congruent angles. So this angle and this angle are congruent. We're going to mark them with these little congruent marks. We'll call this line M. This theorem says that if this angle and this angle are congruent, then line L is perpendicular to line M. Sometimes theorems seem so obvious, it's like, why are they pointing that out? Okay, yeah. If this angle and this angle are congruent, those 2 lines are going to be perpendicular. They're going to be 90 degrees. Okay? The next theorem is numbered 3-4-2. So this is Chapter 3, Section 4, the second theorem, and it says this. It's called the perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other line. Okay, so if we have 2 lines, we'll call this line N. I wrote M, sorry. And here's line P. These 2 lines are parallel, so I'm going to draw a little caret on each of them. And that third line Q, this theorem says if Q is perpendicular to N, then Q will also be perpendicular to P. So if Q is perpendicular to N, then Q is also perpendicular to P. It's perpendicular to one of them, it's got to be perpendicular to the other. The third theorem is 3-4-3. So Chapter 3, Section 4, third theorem, and it says this. If 2 coplanar lines are perpendicular to the same line, then the 2 lines are parallel to each other. All right, so we're going to draw 2 more lines. Line R, line S. Here's your third line. And it says that if line T is perpendicular to R, and T is perpendicular to S, then R is parallel to S. Okay? Finish copying that down, and then we will talk about your assignment.